phrase. Hakuna Matata. It ain't a. Oh, hey guys, what's going on? Memes here. Yes, TGIF. Is there anything interesting going on in the world? Wait, what's this? Spider dragline silk as torsional actuator driven by humidity. Why is always got to be spiders? Here's the intro.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
Guys, what's going on? Memes here again. Yes, that's right. Why the heck does it have to be spiders? Arachnophobia was a very scary movie, at least based upon this observer. So what are we all talking about here? If we take a look here at this beautiful spidery silk. Oh yes, look at it. It's glimmering with those dewdrops and everything. And I actually remember hearing about this maybe probably several months or so ago, because we were talking about like actuators and potentially using spider silk, because apparently it's supposed to be close to as strong as diamond, or at least that's what some people said at one point and everything. It is quite strong. It is quite strong. But this we see there. Hail Paradise. Oh, we doing, my friend? Yes. But what's this all got to do with anything here? So what we're going to do over here is I'm going to pop over here. And this is from advances.sciencemag.org. Yes, the abstract here. The self-powered actuation driven by ambient humidity is of practical interest for applications such as hygroscopic artificial muscles. We demonstrate that the spider dragline silk exhibits humidity-induced torsional deformation of more than 300 degrees per millimeter. Wow, that's a lot. When the relative humidity reaches a threshold of about 70%, the dragline silk starts to generate a large twist deformation independent of spider species. The torsional actuation can be precisely controlled by regulating the relative humidity. That's pretty cool. The behavior of humidity-induced twist is related to the supercontraction behavior of spider dragline silk. Basically, that's the silk that they have, where if all of a sudden the spider starts falling, they literally let out like a parachute of silk, and sometimes you see spiders go along, and sometimes they may or may not land on your girlfriend, and they might kind of freak out. These things happen. Some people don't like bugs. I apologize to my arachnid friends. I apologize for misspeciesing you. Hey, as well as welcome, Geek Studios. Welcome. We're going with some spidery things because it might actually help us explain space-time in and of itself. So we're going to see what happens here. But as we can see, yes, specifically the molecular simulations of MASP1 and MASP2 proteins. I remember seeing a diagram. I actually may have covered this a little while ago. We might have a video. When you've been doing these stuff and things for a while, you actually end up to the point where it's like, I have a video on that. Let me share. Hopefully, so you don't need to say it again, even though you often have to say it again. Now, all right. Torsional properties from the presence of proline MASP2, from what I remember, is basically one of the spider silks kind of shapes there, kind of look one way, the other one kind of look the other way, and then they just kind of twist to get kind of more like this. Yes. MASP2, the large proline rings also contribute to steric exclusion and disruption of hydrogen bonding in the molecule. That's fascinating. I don't even necessarily know what that means. This property of dragline silk at structural origin can inspire novel design of torsional actuators or artificial muscles that enable the development of designer biomaterials. What the heck is all that trying to say there? I see you there, LDG. Welcome, my friend. But essentially what they found out is if all of a sudden you have a spider web, specifically this is the emergency OS silk they have, they're dragline. So you expose it to humidity. Once it gets to a certain point, just the humidity in and of the air, and seeing as the silk line in and of itself is pretty darn thin, it actually just starts to twist and it comes together. So when you go back to this little picture that we had over here, you see, because it's like, wait, water can be pretty heavy. If you ever lift a gallon of water, yeah, it ain't light. It's pretty dense. We also have to put in nuclear reactors for that one of those reasons as well, because it also cools and it often doesn't really interact with too many things in a terrible way, usually. Now, you see those dewdrops there and everything. If you look at a spider web, it's really dry out. Sometimes you kind of see it fluttering in the breeze a little bit there. But when it has there, it also makes sense because it's going to contract. It doesn't want to break because then the spider needs to do all this energy and stuff and things. And the spider's going to follow entropy. It's going to try to be the best dang spider it can be. But the other thing is, I was actually looking for this article and I found another little thing here. This is from Applied Physics Letters. Citation. Peculiar torsion dynamical response of spider dragline silk. This was actually, I think, even a more recent. No, actually, this was a few years before. The abstract. The torsional properties of spider dragline silks from Nephilia edeus and Nephila pilipes spiders. I apologize for butchering your genus and or species. I forget. I'm not a biologist. It's Professor Weinstein. Now, are investigated using a torsional pendulum technique. A permanent torsional deformation is observed even after a small torsional strain. Permanent, you say? This behavior is quite different from that of other materials tested here, i.e. carbon fiber, thin metallic wires, Kevlar fiber, and human hair. The spider dragline thus displays a strong energy dissipation upon the initial excitation, around 75% for small strains and more for a larger strain, which correspondingly reduces the amplitude of subsequent oscillations around the new equilibrium position. All right, what the heck is that trying to say there? As far as I can tell, is they're trying to say that it actually, when you're trying to pull on it there, it actually will start to almost twist there in order to help make it stronger to reduce future vibrations. So, i.e., fly hits the web, okay, it's going to try to tighten up, absorb that, and reduce the vibrating. Because if it keeps on vibrating everything, one, the spider might fall, and two, might damage the web. And again, if you want to be the best dang spider you can be, you want to be as efficient as possible. The variation of torsional stiffness in relaxation dynamics of spider dragline for different excitations is also determined. The experimental result is interpreted in the light of the hierarchical structure of the dragline silk. This was brought to us by National Hubei province. Oh, I thank you, friends. Zhejiang, Wuhan. As we can see, this was actually covered in technological networks as well. So they go over the spider drops from the sky, bada boom, bada bing. All right, I forgot to list these articles in the thingy below because I'm totally a professional YouTuber. So what is my interpretation? All right, we're good with that. And as we can see, but what I'm postulating as well as our proposed hyperbolic reality, i.e. the hyperbolic figure-8 knot and or its complement that's weaving together a particular hyperbolic lattice that ends up being space-time in and of itself. How do we get to gravity? How do we get to these different stuff and things here? Now, again, my video yesterday was basically covering how things on certain scales like waves, whether it's within the ocean, whether it's in the realm quanta there, or on the scale cosmic via gravitational waves and everything, we tend to see very similar things. So you can even see it right over here because there's a light, there's actually sunlight because I'm doing this early enough as well, and some of that's canceling out because the chroma key is tuned to the vast majority of the area. Yes. But what I'm saying is, if you happen to have some form of this hyperbolic lattice, if the spider silk adjusts when different things interact with it, could it not be the same with something like, I don't know, a light? If you had a hyperbolic lattice of space-time in and of itself, what happens if, depending upon the number of photons that run across it, or pretty much anything traversing it, if there happens to be some permanent deformation there? Because apparently some light, when it comes to us, it seems to be more intense. Some seems to be less intense. Sometimes you'll hear red shift or blue shift, but apparently, I'm pretty sure I heard somewhere it could be more energetic as well. And depending on that level of energy, it also corresponds to almost how much it curves. What happens if you have something like that may adjust everything traversing along it, and or if just mass, like you got the Earth, you got the Moon, you got the Sun, isn't that a lot of potential energy? Even if it's not an energy form, if energy equals mass times velocity squared, if you got something big like a hunk of rock like the Earth, isn't that a lot of potential energy? Might that be putting almost a strain on the web in and of itself? So it's almost tugging, if you would. It's almost like you got two bodies, you got the Earth, the Moon, this and that. It's going to be some form of a tension. It's almost holding that energy there. Now, is this likely exactly what's happening? Probably not. Do I have any additional evidence for this yet? No. Again, I'm just putting this out there because, again, we do seem to see a lot of these same observations again and again. And if we keep on looking for these gravitons and everything, but we're not finding them, maybe we just haven't found them yet. Or maybe there's an easier explanation. What if it really is a tangled web that we weave? What if it really is that space-time in and of itself, we're here, and all of a sudden we're just tugging on it a little bit, and we're seeing this actual force in and of itself? Wouldn't that also help explain why stuff that's really far away doesn't interact quite as well? Kind of following like the Newton inverse square law to the point where it's like, yay, is there even an effect? I mean, we're all kind of entangled here. It's all connected. But I don't know. I'm just saying that if you have a very particular characteristic that's already within nature, I don't know. I'm pretty sure there's some smarter folks than me that if we were to try to start to model this in some way, it might be interesting. That, and also maybe the other day, and again, this is completely unrelated, when I took the Planck temperature and divided by the Planck time, and then divided all of that by the Chandrasekhar limit, basically the actual equation that's like 1.4 times the masses of the sun, to basically the limit at which you're tending to have black hole forms. The funny thing is it came out to be like 9.4 times 10 to like the 44th or something like that, which coincidentally, if you were to translate those kilograms per second to actual photons, that's approximately the amount of visible photons per second that the sun happens to emit. I'm just saying, again, I'm not saying correlation does not equal causation. I'm just saying that Wolfram Alpha is a beautiful tool. I'm pretty sure if we had some more folks using it with the power of this internet, being able to find those flags and everything, I'm just saying, I think we could solve a lot of stuff a heck of a lot faster. That's all I'm saying. I see you there, Doc Smith, as well with SSM. Thank you. I only smoked half a stock many years ago. I don't think it really did anything because there was probably other drugs at the time. Now, I wouldn't mind necessarily doing some Cybacillin. I've been told I kind of act like it. But that's all I got for right now. Peace out, everybody. Be safe. And no matter what happens, you gotta remember.
I put the fires out. You made them worse.
That was the wrong clip. See you, everyone.
How do you know if any of this stuff is true? How do you know someone didn't just make it up?
What? You mean just lie? You really think someone would do that? Just go on the internet and tell lies?
I just mean that some of the details...
Whoa, I never thought of that. This is terrible. What if none of it's true? What if they're all lying? How would we ever know?
Have you guys checked out the Memes of Destruction's channel? he's an interesting dude. I like him.